Hi, my name is Sena ERDOÐAN and this is the trailer video of my graduation project, Symbolic Linear Algebra. I will start by explaining what a symbolic matrix is first. A symbolic matrix is essentially an infinite matrix that has no dimensions. We give it dimensions and then we get the matrix with the sizes we want. It has conditions and values like this. If row and column conditions are satisfied, we give this value to that element. And this is an example of it. We have matrix A5 here, for example. These are the cases and these are the values it gets. And this is a 10 by 10 matrix. For example, if column 1, the column number is 1, those values will all be 0 and we can see that it's satisfied here like this. Matrix A1 is still a 10 by 10 matrix, but we can see it has fewer cases, so it's possible to cover more elements with fewer cases. Matrix A2 has the same conditions as matrix A1, as we can see here, and the same values. But this is the 50 by 50 version of the same symbolic matrix, so this still goes on until infinity. If we wanted to have a 100 by 100 matrix, we could still have that. Matrix B1 is a 10 by 10 matrix with these conditions. If we want to multiply this matrix by 2, the cases stay the same and the values are multiplied by 2. We can see that 5, 1, 0 becomes 10, 2, and 0. Matrix C1 is the addition of matrix A1 and B1 together. We have 1, 6, 1, and we have 5, 1, 0, and we can see that this is the addition of those values 6, 7, and 1. This is still an infinite matrix. If we want to get the 50 by 50 version of this, we will still get the A1 and B1's elements added together. These are the row operations. This is the matrix we start with, for example. If we want to switch row 1 and 2 to row 1 and 2, we just switch their places like this. Nothing changes for the elements. If we want to add row 1 and 2 together and write the values on row 1, we can do it. 0 plus 1 makes 0, 5 plus 5 makes 10, and so on. If we want to multiply row 1 by 2, we can do that too. 1 multiplied by 2 is 2, 10 multiplied by 2 is 20, and this goes on for the rest of the matrix. Using these row operations, we can do Gaussian elimination. For example, we have a 2 by 3 matrix here. To solve this system, we need to have -1 as x and 4 as y. And my project is about doing these operations on symbolic matrices.